first, we have to thank our sponsors. So Minnesota Soybean Research and Promotion Council got us started off. So they provided us some seed money in 2021 and 22, so we could have that particular year under our belts. And then we applied for other grants as well. So for the remaining 3 years of these trials, we have some funding through North Central SARE. We've had help from Agassiz Seed and Supply. So in the first year, they provided our rye seed. And then we have the Minnesota Wheat Research and Promotion Council and the Minnesota Association of Wheat Growers. Bayer has provided us some glyphosate, and then Minnesota Ag Services is involved as well. So here's the team. There's a large team of people that are involved in these trials. So me, my colleague Jody DeYoung-Hughes, she's an educator that works down out of the Wilmer Extension Office. She's a tillage specialist. Our soil health specialist, Anna Cates, she's involved in measuring a lot of the soil health practices, or excuse me, soil health metrics. Lindsay Pease, she is a nutrient management specialist, so she looks at a lot of the nutrient cycling sort of data that's part of the trial. And then we have a whole series of technicians, so that's the U of M team. I put in bold Missy Carlson and Dorian Gatchell. In my mind, those are our two most valuable players. They both have been really instrumental in coordinating the on-farm portions of this particular trial. We have some soil and water conservation district folks involved, and then last but not least, definitely not least, is our farmer partners. To maintain their anonymity, I'm leaving their names off here, but they've participated, some of them 2 years now. Some, this is their first year participating, but in the Northwest and the West Central part of the state, we have had wonderful farmer partners. So here's our research location. So this is a map right here. So we had 6 on-farm locations in 2023. We had 2 small plot locations, and these were at our University of Minnesota Research and Outreach Centers in both Crookston and then Morris as well. So on farm, these are field-sized plots. They're as wide as the farmer needs to accommodate his equipment. Like I said, we have locations in Northwest and West Central Minnesota, and I'm going to focus on the Northwestern locations. So these are Fertile, Fisher, and Gently. So at all on-farm locations, we have the same treatments. They're all randomly assigned in the field. They're all replicated. There's the no rye treatments, and the rest of them have cereal rye planted the fall before. Those treatments then are cereal rye that's terminated in relation to when we plant our soybeans. So 1 to 2 weeks before soybeans are planted, at planting, and 1 to 2 weeks after soybeans are planted. So in the Northwest, we have all of our trials are after wheat. We figured that's where a cover crop like this would be easiest to include in our existing cropping system. And so at 2 of our locations, this is Gently and Fisher, those were drilled. So 30 pounds of rye was drilled after wheat harvest. At our Fertile location, the seeding rate was doubled, and that's because he broadcast the seed and then tried to incorporate it. So one of the things that we do a lot in these types of trials, wherever Missy is, we spent a lot of quality time together in the fields collecting rye biomass. So basically, this is a very high-tech procedure where we take a quadrat, so a nice PVC square, and we take a scissors and we go out and cut rye. All the tissue above ground is cut at multiple locations throughout each plot, and then that's dried to constant weight. So this, we need to know how much rye was there to better understand its effects on soil health parameters, on nutrient cycling, and largely on soybean yield. So just as a point of reference, one large square bale is about 600 pounds. This year, we collected between 8 and 175 pounds of rye per acre. So this is 1/75 to 1/3 of a bale. Now looking back at 2022, we couldn't have had two more different years. And so I feel like in these last 2 years, we've kind of seen the extremes. So in 2022, we had between a quarter of a big square bale and more than 8 big square bales. So we can grow a lot of rye biomass when soybean planting is delayed by about a month. So I'm going to go through each individual location one by one, telling you a little bit about each location and then presenting the yield data and then some of my theories for why we're seeing what we're seeing here. So I'll also include a little map like this too, just to reference the location for you. So we had a Gently location. This is a loam soil. This was a location where rye was drilled after wheat harvest. The farmer, before he planted the rye, he practiced fall vertical tillage. Rye was drilled in September 22nd, and then he planted over 2 days, May 19th and 20th this year. So these pictures just go to show you, they were all taken at the same time, and it just shows you how much, in this case, wheat residue. So this is our fall vertical tillage plot, so there was 0 rye here. But the rest of these treatments had rye that was terminated at different timings. And so along the top, this DBP, that's days before planting. Here's planting date, which was May 19th and 20th. And then this treatment here was 12 to 13 days after planting. So those were when the rye was terminated. So at this particular location in 2022, they produced the most rye, more than 4,800 pounds per acre of rye. This year, when they terminated before planting, only 8 pounds per acre. Waiting a little bit and terminating at planting, 28 pounds of rye per acre, and then waiting a little bit longer, so 12 to 13 days after planting, they only produced 72 pounds per acre. But Missy's talked several times this year about how hot and dry it was, and so I'll share some of that data with you in a second. But first I'm going to explain this graph. It's complicated, and I'm going to be showing several of them, so I want everybody to be on the same page. So along the bottom, so the x-axis, are different treatments. The left-hand y-axis, this is yield. The right-hand y-axis, this is our rye biomass. Rye biomass, just to remind us of how much was produced, is this gray line. Those red bars, that's our yield. The red numbers above the bars, that's the average yield for that particular treatment. And then those little white letters within the bars, that's our statistics. So if a treatment has the same letter as a its neighboring treatment, for example, that means they're statistically similar to one another. So what you can see here at this particular location, if they were able to terminate before planting, there was no yield penalty. So here, yield hovered around 41 bushels per acre. If they waited until at planting, lost about 3 bushels, and waiting until after planting, they lost an additional 4 bushels. So the larger goal with these 4 years of studies in all of the different locations is to figure out that sweet spot. We want this cover crop around to hang on to our soil. We don't want soil to blow like it tends to blow around here, but we also don't want to harm our cash crop. And so with these 2 years of extremes and our multiple years and locations, we're hoping to be able to better model when we're going to be successful and when to cut the rye off. So here's what I was talking about. So on the left there, so these maps are really nice. They come from the Midwest Regional Climate Center. Anybody can make them. All you need to do is sign up for an account. Like Missy said, Climate Field View, when I used that to try and figure out how much rain fell between May 1 and September 30th, I was getting up to 44 inches of rain. So I chose to rely on a little bit more reliable resource, at least in this year. And so the graph the picture on the left shows that between May 1 and September 30th, we had between 9 and 10 inches of rain. This is a lot less rain than we would typically get, between 4 and 6 inches less for the entire region. On the right, you'll see that's our average May temperature. So this is averaged across the highs and lows for the month and across every single day of the month. So we were 7 to 8 degrees warmer than normal throughout May. June, we were between 5 and 6 degrees warmer than normal. So we were warm, we were dry as well. So that's really what I'm using to explain what we saw at that particular Gently location. I think that's, even when you have a small amount of rye there, if it's around a little bit too long so that it decreases that soil moisture, that's when you can see some significant yield losses, particularly in a hot, dry year. Our next location is Fertile. So this is a very fine sandy loam soil. This gentleman, he chisel plowed after his wheat last fall. He broadcast rye and incorporated in, that was September 26th. Soybean was planted on May 20th. So those were the latest planted of our 3 trials we're going to talk about here today. So at this particular location, in addition to being hot and dry, it was also very windy. So he wasn't able to get out and terminate before planting. And so we only have 3 treatments here. We have the no rye treatment, we have the termination of the rye at planting, and then after planting. So when rye was terminated at planting, he was able to grow 65 pounds per acre. 10 days later, that was up to 106 pounds per acre of rye. So here's a similar graph. So again, the line reminds us of the biomass, and then the yield data is in the bars there. No rye out-yielded the other 2. So we lost 3 bushels when rye was terminated at planting. an additional 4 bushels when rye was terminated after planting. It would have been really nice to be able to see what happened before planting, but we just don't have that. He did see higher yields in the field area surrounding the experiment, and the only differences being that he used a pre-emergence herbicide and planted in narrower rows, so 15 inches versus 22 in our trial area. One last location, this is Fisher, this is silty clay loam, so no-till, he practiced no-till across the entire experiment, and planted rye, he drilled rye in after wheat was harvested with a stripper header. So this was the nicest, thickest canopy we saw. As you can see here, we did see some of the rye still standing up there. And when he waited until 12 days after planting, he did produce up to 175 pounds per acre. We didn't see any differences among treatments, but one thing you might notice, this was a very high-yielding experiment. I know Missy was excited because I think that she had never helped with harvest of an experiment that yielded 60 or above 60. But statistics, I mean, there was a lot of variability in this trial. You will see that numerically speaking, all of the rye treatments had higher yields than the no rye treatment. Here's a couple of theories as to why maybe we saw what we did. And they're just theories, and I'd be happy to entertain any of your theories as well. So obviously, same hot, dry conditions. It was the earliest planted location though. And maybe the rye and the standing wheat helped to provide some, additional root channels there to allow infiltration of rain we did get. Maybe it also helped to shade out the soil and reduce some of the water loss that way. So key findings, your chances of not having a yield hit are best the earlier you terminate your rye. So if you terminate before planting, in the 2 years of our trial, you only have about a 20% chance of reducing your yield. 45% chance of reducing yield if you wait until at planting. And then after planting, odds are you'll probably, after planting, you'll reduce your yield, so 54% there. So my colleague here, Lindsay, is ready to go.
Can't figure this. All right. Yeah, thanks, Angie. While they just get this set up, and I know we're pushing the time a little bit. I'm just going to go kind of quickly and what I looked at. We have also been looking at the. Where's the clicker? It's okay. We've also been looking at what's happening in the soil in terms of nitrogen and nitrate availability in these plots. We are still analyzing the data that we collected back in 2023, but I did have a little bit of data from 2022 when we ran this experiment that I wanted to real quickly go through today. Yeah, so I was going to talk again about this Gently site, which is one of the ones we had both in 2022 and in 2023. The previous crop was wheat. Rye was drilled, and there was a fall vertical till, just like in 2023. This is, and Angie mentioned this is what our rye in pounds per acre looked like on the field in 2022. And Angie set this up great, saying just what a huge difference the year made. And, if you remember, 2022 was a little bit of a late spring, so that rye really took off in this field. The yield maps, and again, this is just kind of to let everybody know, the yields were really fairly even across treatments. We did see slightly lower yields in that before planting termination timing. But as you can see, even with that high level of rye, we didn't actually see a reduced soybean yield compared to our control. So that's really interesting, especially as we start to dig into, more of these factors that are kind of, we really need to dig in a little bit more about why we're seeing some of these treatment differences, because, you would think for sure, 5,000 pounds of rye would have an effect on the soybean yields, but we just really didn't see that in 2022. So everybody remembers the nitrogen cycle from school, right? Yeah? No, me neither. Me neither. So that's why I have a slide on here just to walk us through everybody and walk everybody through this. And when we have nitrogen, really there's two pools. There's an organic N pool and an inorganic N pool. The organic pool is really what is the form of nitrogen that comes from something like manure is traditionally what we would think of, but also organic matter. So that rye biomass, that's a form of organic N that then goes through a process called ammonification to transform into an inorganic form. Inorganic N is what you would apply with a synthetic fertilizer or urea. It's already in that inorganic form. So the microbes that are in the soil, they don't actually directly take that inorganic N up. They use that process of ammonification. It converts it. What the microbes do, they really mostly work on that nitrification step. That creates that nitrate pool in the soil. That's what you test for when you're looking at fertility recommendations, because that's what is actually being taken up by the plant roots and hopefully transformed into proteins. Now, when you have that nitrate step, that two things can happen with it. Besides it being taken up by the crop roots, it can leach through the soil, or it can be eaten by other microbes and denitrified and released as either nitrous oxide or an inert nitrogen gas. So when we are thinking about soil testing and these nitrate results, today I'm just showing the nitrate results in the soil. So it's really an incomplete picture of what is going on across the whole nitrogen cycle, but it does kind of give us some clues as to what's happening. Okay, so this is what we saw on the Gently field as far as soil nitrate goes. There's 3 different time periods on the graph, and the fall 2021 before planting is the first one. We had in some places of the field more than 100 pounds of nitrate in the soil that we tested, down to the 24-inch depth. This was really a lot, but what you see is then 12 weeks after planting, that nitrate level in the soil has really evened out. So that nitrate form, it's gone. Well, I mean, not really gone. It's been taken up by the plant, and it really evened out across treatments. So what this is showing us is that then our rye biomass didn't really change the nitrogen availability later, 12 weeks after planting. Unfortunately, what we don't have is we don't really know what happened between point A and point B. But we are looking at more intense measurements at the Northwest Rock sites that hopefully will give us a better picture of at what timing that nitrate's going down. My thought is that probably the soybeans did a really good job of scavenging the nitrates that year, and that's why we didn't see really any of those differences in yield. And of course, then by the end of the growing season after harvest, that's the last time period, again, no difference across treatments in what's left in the soil at the end of the season. But we do see maybe a little bit of an increase in nitrate between the 12 weeks after planting. That was kind of late August, and then when these soybeans were harvested in the fall. So, you think about there was kind of a little bit of an increase there. One thing that we have to keep in mind is, first of all, that, I had these out of order. Let me just kind of move forward here. One thing that we have to keep in mind is that we did have a very dry later season. So, one of the things that those microbes need to convert things from the organic form into an available form is moisture. And we had a really dry later period. So there could be organic nitrogen left in the field that wasn't converted. And we only see kind of a little bit of a bump in September. So I think that's explaining why we see kind of that nitrate levels go from like 20 to maybe a little bit more like 30 or 40 once we get into kind of this post-harvest period. The other thing I wanted to mention, which is why I threw this graph in, is that 100 pounds per acre of nitrogen, residual nitrogen, seems really high, but actually it was pretty normal in this particular year. I actually grabbed this off AgVice's website. They had looked at, this estimated how much was left. 2021 was super dry. So, all of those, like, you fertilize for your yield goal and then you don't get rain and you don't get it. About, a third of farmers in this area were in that same boat of having a lot of residual nitrates left in the soil. So what we are hoping to see and hoping to look at moving forward on this project is really looking at those nitrogen transformations a little bit more, thinking about where those are stored, because that soil nitrate data alone doesn't really give us that great of a picture. It just tells us what is or isn't available for the plant at a certain point in the season. So I've been given a 2-minute warning by Missy, which leaves us not very much time to answer questions, but I think both of us will be around later if we don't have time right now.
Does anybody take 1 or 2 quick questions for Lindsay or Angie?
Angie, on your rye, what about stand reduction? Is that the issue with the yield?
We were given 30 minutes, and so I chose to leave that out, but that data is available in the book here. And so offhand, I don't recall, but that has been an issue at some locations. So particularly when you have, so our soybean agronomist for University of Minnesota, Seth Nave, he says when you have 100,000 plants, like living plants per acre, that should be fine to produce, that should be a fine amount of stand in order to produce a crop. If it's below that, which some of these were, that definitely could cause what we're seeing here as far as yield is concerned. But all of that is in the book by location.
All right, one more question.
Thank you. Are you working with winter-killed cover crops? And if that's so, are you seeing some nitrogen credits given to the following cash crop?
Yeah, so these are, it's a rye cover crop, and that is one of the only cover crops that does live through the winter up here. So it's not winter kill.
But my question is, like, if you are working with winter-killed, no winter hardy.
Yeah, we haven't been looking so much at the credit from the winter kill cover crops. I mean, one thing that I feel like we run into a lot with winter kill cover crops is they just don't ever last long enough to be established. We do have some We actually do have a strip till trial where we planted some winter kill this fall, and since we had a warmer fall, that actually had a little bit of an opportunity for some growth, so we might see something, but I don't have any information on that right now.
No, that's great. I was thinking in the rotation that you use wheat, maybe you can establish cool season cover crops like radishes, or even in the Red River Valley, an option could be, I don't know, sugar beet.
Yeah, as far as that goes, I've had success establishing radish once out of the last 3 years that I've tried. Yeah, this year.